Hi, I'm Tom, Doosan Product Support Manager. This is a video clip for introducing new coming electro-hydraulic system of Doosan products. I would like to recommend this video who wants to know the system difference and who need to know the difference for service repairs. Note that this video clip is for our employees and partners only. This presentation contains a brief description of the current Nekicon system, including electronic hydraulic system trends to VVO and FEH systems. Everything will be shared with a total of 3 video clips through the next 2 articles on a regular basis. First, let's look at these electro-hydraulic system trends. If you look at how the system has evolved, it's been developed from Nekicon to FEH. The dynamic flow has been used since the 1980s to the present, including Nekicon, Posicon, and load sensing. Most of Doosan's equipment uses the Nekicon system and partially use Posicon and load sensing. These have such a system that controls the equipment mechanically. VVO is a system that electronicizes the pump a little bit more, that is the signal line that controls it. Intelligent flow control refers to the FEH system that we are using. This will be reflected in a current mass production. In the future, independent metering is a system that completely and independently controls the flow of the pump to cylinder and cylinder to tank. In this case, the effect of improving fuel efficiency could be expected. In fact, it is important to save fuel by reducing losses, so the valve is removed as losses on the valve side accounts for 40 to 50%. After that, PCA stands for Pump Controlled Actuation, is a concept that matches pump per cylinder. And furthermore, the concept of EHA stands for Electro-Hydraulic Actuation, is to have an independent system including power sources. So before introducing VVO and FEH, I would like to explain about Nekicon, the current hydraulic system of the Doosan excavator. One of the many ways to move the cylinder is to control it using Nekicon. The pump first produces the total flow rate into each cylinder, and valve distribute the flow rate per pump. Sometimes people say that valve determines the speed at which the cylinder enters, but that's not true exactly. Some of them are correct, but the amount of discharge does not change if it is a single valve line. This means that if there are more than one valve, the flow rate will be determined by dividing the flow rate. Depending on the pump flow rate, valve stroke, there are Nekicon, Posicon, load sensing, and etc. First, if you look at the Nekicon system, if you move the joystick, push only the spool, as you can see. Push the spool affect the flow rate of the center bypass, as you can see. By default, this bypass line is pressure generated from the foot relief valve orifice. As a result, valves move physically to determine the pump flow rate. It is determined by a correlation between pump and Nekicon pressure in the regulator. Therefore, the Nekicon can only be figured to determine the flow rate of the pump, and the lowest flow rate when pressure is high, and the maximum flow rate when the pressure is small. This is why it is called negacon, because it is determined in a negative form. If we look at some features on the right side, there is a center line where the negacon is kept on standby. There is an energy loss, approximately 50 liters per minute at 30 to 40 bar is supplied in a neutral. For example, a VBO system has an actual standby flow rate is equal to 0. There is a question if response is slow without actual standby. The answer is yes, it is. However, there is a small delay of less than 0.1 seconds, so it's not a big problem as it is not something that you can fill with. You can see the load filling on the chart. The load filling means that when load is high, the flow rate on the line decreases and the actual speed decreases. You can see this graph. The graph showing the loss is shown below. The loss is for 40 to 50% of total loss of the system. When one actuator on a pump is operated, the discharge pressure on the pump is usually a bit higher than the pressure on the cylinder. This is because there is a pressure loss going through the valve. This flow is called as metering, and loss that occurs when receiving a meter-in signal at the cylinder point of view, which is called meter-in loss. The flow rate through the cylinder valve into the tank is called meter-out, and the loss that occurs is called meter-out loss. Negacon needs standby flow, so the loss to the foot relay valve is about 5 to 6% of total power output. As shown in the graph, horizontal axis flow line must be supplied more flow from the pump than actuator. If there are 3 actuators here, the system pressure should be higher than the actual highest pressure and similarly require more flow. This is why there is a meter-in loss when system has the multi-actuators. Negacon's MCV and pump are synchronized well. The actual valve and pump must be synchronized well for flow. The flow rate must be discharged after the valve has been opened, and flow rate must be reduced after the valve closed. Otherwise, peak pressure may be generated or problems occur on the machine. Negacon has little chance of unbalance because these parts are mechanically related to each other. The simulation shows the following. First, pull the joystick. Second, spool is pushed by the pilot line. And then the pressure drops as the flow rate to the tank is blocked, and the pump angle is increased so that increase the flow rate. This is a circuit diagram of Negacon system. You can see the Negacon signal comes from the regulator and determines the pump flow rate. This Negacon signal is a loss from machine's point of view. If you look at this diagram, under load during operation, if the cylinder pressure rises, the delta P decrease. So QA flow rate will decrease. This also increased the QB flowing into the tank. QB increased the pressure of the negative cone, which reduced the pump flow rate. As a result, QP is reduced. And when there are multi-actuators, flow rate will be distributed by load on each cylinder and area of PC notch in the same way. And now we are going to see VVO, Electro-Hydraulic System Controlling Way. First, we need to understand about what electrification is. Electrification means that conversion of a machine or system to use of electric power. This could be changing power to reduce emission, could be changing the actuator's drive, such as cylinders, and could be electrification of control signals. There is a part called control by wire, which means it can be controlled by electrical signals. That is concept of current VVO system. The hardware of MCV and pump is the same, but there is now a difference in the parts controlled by electrical signals. It is not that the mechanism has changed, but it is control signal has changed. This page is for brief description of the FEH system. The FEH system allows electrical joystick signals to enter the CAN line. Unlike VVO, in FEH, PPRV stands for proportional pressure reducing valve. Sometimes we say EPPRV is inserted together per each spool on the right side, as you can see. So this will be your last page of first presentation. The second presentation will be about VVO and FEH system in more detail. Thank you.